This section is 3.3, graphing with intercepts. If your numbers work out nicely, this is a really nice shortcut to graphing by our last method, y equals mx plus b, and works out perfectly when our graph is in this form right here, which is known as standard form, which doesn't really come up that often in our class, but this right here is known as the standard form of a line. And so when we graph using intercepts, we're not required to do the manipulation to get it into y equals mx plus b form. So what does it mean to graph with an intercept? Well, here's our y-axis and here's our x-axis. And so if we have a point, say here, the x value would be 0. We didn't go to the left or to the right any. And the y value would be whatever number up or down it could be. For the x-intercept, we're going to have some point that lies right there on the x-axis. And so the number is actually going to come first. Before it was a hashtag sign, it was a number sign. So this is just kind of my own notation here. And then the y value, notice if we're on the x-axis, we didn't move up or down any, we stayed. And so this represents some number I didn't specify in my graph, comma 0. And here we have, I switched that. Let me undo that really quickly. Let's try this, 0, comma some number. And here we have the number going first, and then the important point is that this piece right here is 0. And if we can figure out what those points are, then we can connect the dots and we're done. So that's the idea behind using the intercepts to graph. Let's put it into practice, and I think it'll click even better. So for the x-intercept, it's in reverse. The y value is equal to 0. And for the y-intercept, the x value is equal to 0. So usually when I do these, I kind of write them in little columns, set it up all nice and neat like that. So here we're literally just going to plug in a 0 for y. So 2x plus 4 times 0 is 20. And so anytime you multiply by 0, that just goes away. So what I was saying earlier is these work out really nicely if the coefficient in front of that x divides evenly into the back number, the constant, this 20. Divide both sides by 2. It definitely does here. I think all of my examples do. And we get x equals 10. So my x-intercept is going to be the point 10, comma 0. Right there. Let's do the y-intercept. We're going to plug in x equals 0, so 2 times 0 plus 4y equals 20. So you know that piece is going to go away. With experience, you can kind of just go, all right, that part goes away, and then you kind of think, okay, this part goes away. You can kind of just even put your finger over that part of the graph, and there's lots of ways to do this relatively quickly. So here we're going to divide by 4, and so we get y equals 5. So don't forget here the 0 comes first in the coordinate, and then the back number is 5. So we just go straight to that y-axis, up 1, 2, 3, 4, 5, and we have 2 points, and that is enough. And we draw the line, and we're done. That's it. Graph using the x and y intercepts. I like to always make my little chart for the x-intercept, y equals 0. For the y-intercept, x equals 0. So let's plug y equals 0 in. That part's going to go away. Divide by 4, divide by 4, x equals 3. So that's going to be a point on the graph here. If I plug in x equals 0, be careful with that negative. 4 times 0 is 0, but I do have this negative right here, so if negative y equals 12 and I divide both sides by negative 1, then y is negative 12. So I have a 0, comma, negative 12 for a y-intercept. My graph, unfortunately, is a 10 by 10 graph, so we're going to draw that and make our own little negative 11, negative 12, put my dot. And there would be the line. A few more to try, or there's one here for you to try. Set up your columns. All right, so let's plug in y equals 0. So negative 2x, when I put a 0 right here, that part just goes away. So feel free to just leave that part off. You know it's going to go. And so x, we have a negative 2 and a negative 6, so x is going to be a positive 3 when I divide. When I plug in x equals 0, this part goes away. So I have 6y equals negative 6. So when I divide both sides by 6, negative 6 over positive 6 is negative 1. And so when I go over here, I have my x-intercept at 3, my y-intercept at negative 1, and I draw my line. Oops, I really missed there. Let's fix that. Like that. There we go. Closer. All right. So intercepts, hopefully, if you were struggling with slope, intercept, x and y intercepts is even a little bit more of a shortcut. It's good for some situations, not all. So very problem dependent, depending on the application you're looking at. All right, also in this section are horizontal and vertical lines. We have not discussed yet what happens if you have an equation of a line that's just flat here. What happens if you have one that's straight up and down? If you've watched the slope video, we touch on this also in the slope video. So horizontal lines are y equaling some number. For example, you could have y equals 4. So if that is your whole equation of the line, not just a point on a number line, but on a coordinate grid, if this is the equation of the line, where is y equal to 4? Up 1, 2, 3, 4. And it's not just a point, it's the whole line. So it is a horizontal line through 4 that goes forever. Notice how there is no x-intercept. It's parallel completely to the x-axis. Over here, the same idea in reverse. Vertical lines are x equaling a number. For instance, x equals -5. Here's our x-axis. Let's go left, 1, 2, 3, 4, 5. It is not just a dot. I just needed that as a reference point. It is a vertical line through -5. Notice how there is no y-intercept on a vertical line because it is parallel to the y-axis. Remember, if you've watched the slope video, the slope here, if you haven't, no worries. The slope of this line, considering it is completely flat, the slope of this line is 0. And slope is also considered to be kind of like the steepness. If you think of driving up a mountainside or up a hill, this is so steep that there's no way you could drive up a hill like that. So the slope of vertical lines is undefined. Let's do another one. All right, here I have us drawing a few on the same graph, just so that you can kind of compare. So if we have a number now in front of that x, we can easily divide that out. So if we have 3x equals 9, let's get that x by itself. And we would have x equaling 3. That would be a vertical line through 3, 1, 2, 3. And I just put that dot there because sometimes just staring at this computer screen can be hard to find those reference points. So there's that vertical line. Y plus 2 equaling 1, y plus 2 equals 1. Let's get y by itself by taking that 2 to the other side. It is going to be a horizontal line, so this one's going to go the other way. Where is y equal to negative 1? Down 1. So it would be, I would lie if I'd say, I would be lying if I said I don't enjoy playing with some of the colors here on my little tablet. So there is the line y equals negative 1. And then I included one with 0 because sometimes that is confusing for students. Where is the line x equals 0? Well, where is, it's going to be vertical. All right, so we know it has to be a vertical line, and we are not going to go left or right any. So the line x equals 0 is actually the y-axis. So if you were going to graph that, if you were going to graph it on paper, I would suggest getting some different colors. But that is the line x equals 0. It is the y-axis, and I thought that was worth mentioning, even though I didn't really see that in the book per se. I'm sure you're expected to know it. And then if we just extend that idea, this piece right here, the x-axis, it's horizontal. And since we didn't go up or down any, we haven't gone up or down any. So like this is y equals 2, y equals 3, y equals 4. This one we didn't go up or down any. That is the line y equals 0. So I hope that helps. All right, let's graph these on the same graph. Here is another just extension type problem because I think students struggle with this sometimes. These two lines are not the same, so we need to kind of read carefully. This guy right here does not have an x value. This is a horizontal line through 4. So up 1, up 2, up 3, up 4. There is the line y equals 4. This line right here, though, has an x. So this has a slope. This is 4 over 1, and there is no y-intercept. So this is the line y equals 4 over 1x plus 0. So I am going to, let me change colors here. I'm going to put my y-intercept at 0, and remember you're going to count up 1, 2, 3, 4, right 1. Count up 1, 2, 3, 4, right 1. And I've just seen students too many times get those concepts confused. It's like once you know one thing, you've got it, but then when you add lots of things and have to keep them straight, that is when math sometimes can get a little confusing. So that is that line there. All right, I hope that helps with anything you have with the x's. All right, and that's the end of that. All right, so that one was relatively short compared to the previous lesson. And then we're going to get into what's coming. What is coming is some application problems with slope. So the next two lessons actually deal with slope. So take care, everybody. I hope you're finding success on the homework.